You are listening to The Vocal Technologist. Spoken tech for your ears.
I feel like I need a crash helmet just to read the tech updates in the morning. Seriously.
Oh, I know that feeling.
Every single day there's a new, trillion-dollar valuation, some new chip design, or a project that's so ambitious, it makes yesterday's breakthrough feel like a software patch.
It's moving at an incredible speed.
It is, and it's moving so fast that you really need a guide just to figure out where the actual money is going and where the real power is actually shifting.
Right.
And that's really our mission for this deep dive. We want to cut through some of that complexity. We're not going to talk about what gadgets are coming out next year. We are diving into the absolutely staggering capital, the hardware innovations, and the really critical strategic deals that are happening right now that they'll dictate the future of the AI race.
And what's so fascinating is that the biggest stories aren't really about consumer features anymore. They're about these hidden infrastructure wars.
The plumbing.
Exactly. The plumbing. We're talking about the sheer scale of computing power that's being bought or built or even, launched into orbit. These are the decisions that will shape things for the next decade.
Okay, so let's start with the numbers then, because it really feels like compute capacity has become the most valuable commodity on the planet.
It is the new gold. I mean, look at OpenAI. They just signed a multi-year deal with Amazon for cloud computing power.
And the number is?
It's worth a stunning $38 billion.
$38 billion.
Oh.
That is it's an incredible number, especially when you think about how exclusive their relationship with Microsoft used to be. So what does that mean strategically?
Well, it shows two things. First, just the desperate race for scale. They're facing what they call severe computing shortages.
Even with all that revenue.
Even while generating, $13 billion in revenue this year? So to grow, they need compute wherever they can get it, and they are willing to spend whatever it takes.
And the second thing?
It's a really shrewd hedge. By spreading their dependence out, across multiple providers, they're protecting themselves against price hikes or regulatory risk tied to just one partner. It also tells you Amazon is ready to play at the absolute top tier.
So you have the cloud deals, but then you have the hardware battle on the ground. Specifically, the challenge to NVIDIA's dominance. Google's making a big push here.
A very strong push with their latest Ironwood TPUs, the V7 accelerators.
And this really brings up the big question, right? Can anyone actually catch NVIDIA, or is CEA just too big of a moat?
That is the question. And Google is certainly trying. If you normalize the performance, so you're comparing the raw number crunching power fairly, their Ironwoods are actually getting pretty close to NVIDIA's Blackwell chips.
So performance is one thing, but the real difference from what I can see isn't just the speed of one chip, it's the scale they're offering.
Absolutely. The key is scalability. Google offers these TPUs in these huge, tightly integrated pods. They start at 256 accelerators and go all the way up to 9,216.
An enormous number.
It is. And that ability to deliver these massive unified blocks of power for training the largest models, that puts real pressure on the market. It just simplifies the engineering so much.
And if that wasn't enough, the literal cost of electricity on Earth is pushing big tech to plan data centers off-world. This is where it gets really wild.
Yeah, we're seeing two serious plans for space-based infrastructure. First, you have Elon Musk suggesting that the future Starlink V3 satellites could become orbiting data centers.
Which would require a massive leap in, everything. Hardware, launch capability.
Totally. The V3 satellites are enormous, something like 2,000 kilograms each, and they transmit data at up to 200 gigabits per second, but they're so heavy that he needs Starship to be finished just to get them into orbit.
Meanwhile, Google's taking a different approach with Project Suncatcher. They're tackling the power problem directly.
Right. They want to put dedicated AI data centers into orbit, specifically to get constant sunlight, to solve that electricity cost problem we have on the ground.
And how does that work?
They're planning to use a dawn-dusk, sun-synchronous, low-Earth orbit, which basically means they get uninterrupted sunlight. But the engineering hurdle is it's massive. They need solar panels that are 8 times more efficient than what we have now.
8 times? Why such a huge leap? That seems almost impossible.
It all comes down to the physics of a rocket launch. To power thousands of TPUs, you need phenomenal wattage. But you have to generate that from panels that are light enough and small enough to fit in a rocket, so you need density.
So efficiency equals density.
Exactly. And on top of that, the TPUs themselves have to be rugged enough to run for at least 5 years in space. They're planning to launch some prototypes by early 2027.
Wow. The idea that kilowatt hours here are fueling a space race for data centers, that really puts the AI energy problem in focus. Okay, let's pivot from infrastructure to the product edge and some of the ethical frontiers this is opening up. We had to talk about the Apple and Google partnership.
That deal is just fascinating. It really shows how much Apple prioritizes security. They're close to a deal to pay Google about $1 billion a year.
$1 billion a year? For what exactly?
For access to a custom 1.2 trillion parameter Gemini model. And this is specifically to power the new Siri that's supposed to launch this spring.
So Apple is basically renting Siri's brain, but keeping total control over the data.
That's it, exactly. Their whole strategy is to run that massive model on their own private cloud compute servers. They're buying the intelligence, the reasoning capability, without ever giving up control of the user's data.
They're licensing the model, not the infrastructure.
You got it.
Speaking of control, let's talk about the strategy behind Elon Musk's staggering pay package. Tesla shareholders just approved it, and it could be worth, what, $1 trillion?
A potential value of $1 trillion, yes. The plan could grant him that much in additional stock if he hits all the milestones, which would increase his voting control to about 25%.
And he didn't really frame this in purely financial terms, did he?
No, not at all. He claimed he needed such a large stake to make sure his robot army, his AI assets, doesn't fall into the wrong hands if he were ever fired.
So we have to ask the question, is that a real ethical concern? Or is it a financial strategy that's just dressed up in ethical language?
It's the key question. Does this idea of ethical control through massive financial ownership set a dangerous precedent for other founders?
That's a huge shift, framing compensation as a form of existential risk management. Okay, let's move from the corporate world to some very futuristic and ethically charged science. First, artificial wombs.
This is a technology that could just profoundly rewrite the limits of what we consider viability. Premature birth is the nation's second leading cause of infant death.
And these could save more of those babies.
That's the promise, yes, by providing a controlled external environment.
But the ethical problem is immediately obvious. If we can save babies born much, much earlier, where does the line of viability move to?
And that is the core legal and ethical fight. If viability shifts, the entire legal status of a fetus changes. It forces these incredibly urgent questions about parental rights, state intervention. All of it has to be answered before human trials can really begin.
It's a practical, clinical rewriting of when life begins.
It is.
And on the other end of the human experience, we have this mind-captioning technology. This feels like it's less about biology and more about the final frontier of privacy.
It really does feel like science fiction. This AI uses brain images to generate text descriptions of what people are seeing, or even just visualizing.
Just visualizing?
Yes, based only on their neural patterns. And what's really stunning is they achieved about 50% accuracy even when people were just imagining scenes in their mind.
50%. For a thought, if that technology gets better, the privacy implications are terrifying.
They are. You go from a useful tool to a massive privacy problem very, very quickly. If it's 50% now, what is 90% in 5 years? Could your operating system just caption your internal thoughts about a product you see?
It forces you to define what mental privacy even is.
Right.
Okay, let's shift gears now to the developer world. Because the dominance of these big language models is creating a weird dilemma for innovation.
Yeah, we've been calling it the dead framework dilemma, and it's a genuine strategic worry.
Explain that.
Since these LLMs are trained on, all the successful code that already exists, it becomes incredibly difficult for a brand new framework or library to get any traction. The models just don't know about it.
So they can't recommend it, they can't debug it.
They can't do anything with it. It's like having a brilliant senior developer who only knows the tools from 10 years ago. And, as the vocal technologist, this is the kind of deep strategic problem that I think we really have to flag for people.
So the industry risks just building the future with old tools because the AI reinforces the status quo.
It's a real tension. But alongside that, we are seeing some important updates to current tools that are focused on trust and flexibility.
Like GitHub's immutable releases, which is a big security win.
Oh, it's essential for supply chain security. It basically protects your software assets and tags from being tampered with after you publish them. Once a release is tagged, it's locked.
So no one can sneak in malicious code after the fact.
Exactly. No rollback attacks, no substitution attacks. It just makes everything more trustworthy.
And then finally, on the tools front, HTMX just had a big 4.0 update.
They did. They really streamlined the foundation. They finally replaced the old XML HTTP request object with the modern fetch API.
Which every developer will be happy about.
Everyone. And it's not just a swap. It means better handling of asynchronous stuff, cleaner code, just more efficient all around.
And they also changed attribute inheritance, right?
Correct. It's now explicit instead of implicit, which should cut down on a lot of weird bugs and headaches. It's all about stripping out complexity to make the tool faster and more predictable.
Wow. Okay. We've gone from deals worth $38 billion and $1 trillion to hardware built for orbit and tech that can caption your thoughts.
It's been a monumental tour.
It has.
And if you connect all of it, the main idea is pretty clear. The competitive edge today isn't just software features, it's pure physical infrastructure and massive capital deployment.
Which is challenging everything.
Everything. Chips, cloud, ethics. Knowing these details is just critical for understanding where technology is actually headed, no matter what your role is.
Absolutely. And as we finish up this deep dive, here's a final thought for you to chew on, tying together this immense flow of capital into automation and what it means for human work.
We've talked about the huge cost of building this AI supercycle, but what happens to the jobs that just cannot be automated?
Good question.
Consider this paradox. As AI makes some things orders of magnitude cheaper, driving these huge productivity gains, the wages for specialized human labor that can't be automated will actually go up.
So they'll command wildly high wages. Why?
Because those people, the great therapist, the AC repair tech who can diagnose a really weird failure, the critical human decision maker, they still have to compete for talent in the same high-wage labor market that the AI supercycle created.
Ah, I see.
So you could end up in a world where some things are virtually free, but irreplaceable human work becomes incredibly expensive. Think about how that divergence could fundamentally change our entire service economy.
Spoken Tech for your ears.